Hello, in this video I will explain the Born-Haber cycle to form Sa3NW, and I'm going to find the bond dissociation energy of NW2. So I'm going to start by preparing Sa anion gas, and I'm going to start off by having Sa as a solid, and I'm going to sublimate it so I can have it as a gas. So the sublimation energy is this, and since I need 3 SAs, I'm going to multiply all of them by 3. Now that I have my Sa as a gas, I'm going to ionize it for the first time. So I have my Sa plus gas and 1 electron. And since I need 3, I'm going to multiply all of them by 3 as well. Now I'm going to find my NW negative 3 gas, and I'm going to start off having NW2 as a liquid, and I'm going to evaporate it so I can have my NW2 as a gas. So the evaporation energy is this, and since I only need 1 NW, I'm going to multiply all of them by 1/2. And now that I have my NW2 as a gas, I'm going to dissociate it so I have my 2 NW gas, and since I only need 1, I'm going to multiply all of them by 1/2 as well. Now that I have my NW2 gas alone, I'm going to add the first electron affinity, and I have NW negative gas. So the first electron affinity energy is this. Then now that I have my NW negative gas, I'm going to add the second electron affinity. So I have my NW negative 2 gas, and this is the second electron affinity energy. Then I'm going to add the third electron affinity to NW negative 2 gas. So I add an electron, so I have my NW3 gas, and this is the third electron affinity energy. Now I find my lattice energy. I'm going to cross off the 3 SA gas with this. And I'm going to cross off the 3 SA anion with this one. The 3 electrons, I'm going to cross off all of these 3. This one I'm going to cross it off with this one with this one, and this one with this one. So now that I have everything crossed off, I'm going to find the enthalpy of formation of Sa3NW. So I was given this, and now I'm going to find my bond dissociation energy, and since I had it as 1/2 here, I'm going to multiply everything on the right times 2. So it's -3 times the sublimation of Sa, and -3 times the first ionization energy of Sa, then minus 1/2 of the evaporation energy, minus the first electron affinity of NW, minus the second electron affinity of NW, minus the third electron affinity of NW, minus the enthalpy lattice energy, plus the enthalpy of formation of Sa3NW. So I'm going to plug in all of the numbers here. So now that I plugged in and did the calculation on my calculator, I found out the bond dissociation energy for NW2 is this.